first attempt already. I hope this time everything will be good. Well, now what do you see? You see your next task, fourth task in a mentor. Last one, what should I say as usually? It's introduction to the mentor, practical class number 12 people. Hello, my dear students. Now you see initial data for your final task and in this discipline, I mean. And remind you that all the tasks altogether maximum point score is 50. It means that second, they were up to 5 points. Please watch the video class number 11 in order not to repeat mistakes of other people. Up to 5 points for each. Next, really maybe challenging task for you about designing of airplane. The most expensive, it's like quarter of your score at all for the whole discipline, up to 25 points if you finish it properly. And this one will cost you 15 points. Yes, 15 points. No, anyway, mentor shows you how much it costs. Actually, this one may be rather simple, and it's maybe the sort of present from me that is cost so expensive. Very well. Let's start talking about this, but before, you already must be see what it comes about. It comes about the sheet metal stamping. And what we are going to do, people, we are going to start our own manufacturing. We have analyzed the market, and maybe even we've been ordered. Someone has ordered us to produce this washer. You see a lot of them. They are different in shape, in material, in thicknesses, and those washers, they are the objects of so-called mass productions. It means that they are necessary in great amounts, and usually this great amount repeatable in rather big programs. It comes about thousands, it comes about millions of these parts. May we produce it, for instance, by laser cutting? Yes, we may, but it will be a rather long process because each contour in this washer you need cut individually. Now, in case it's something complex, somehow complicated, maybe, but not for mass production, certainly. Anyway, if we produce it by milling or whatever another cutting like this, sequential cutting, along the contour, the same problem each time. It will be too long. Economically rational or not, it's necessary to calculate, but too much long, and you need them in great amounts and quickly. So the most obvious way, what? Of course, cutting in a die. You need to cut it in a die, and those operations of cutting in a die, let me to open the book for it. They are called blanking and punching. Right now we see the picture that may be better to use later. As usual, guys, always the same. Let me to show first. Let's see what is the page in this book. This book I'm not going to send you. I will send it to another discipline, about for technologies group, for those who in green lists, let's say. But if you need it, you may signal me in your group in the Ding Talk, I mean introduction, and then I will send it also to introduction. And page number 263, and here we need 86 page. Oh, yes, here is 86 page. Well, the process that we see right now in the scheme may be called either piercing or blanking. What is the difference? No, obviously no difference, you understand. But difference is that it will be different for us in terms of what we got under the punch. If punch intruding into the block resulted in appearing of ready part, it's considered blanking operation. If what have fallen down under the punch, from under the punch, it's wastage, scrape. In this case, it's called piercing or punching, as we might see in another books. Great. I hope you understand where Michael Groove has disappeared. also has opened in the wrong place. In the wrong, I mean that I have prepared some places in this book to show you. No, whatsoever, they are all in slides, those pictures. So we have decided that considering the type peculiarities, part feature, and part feature and part material, we should understand that it's if it's made of glass or something like this, some another fragile material, it's not the good way to produce it to try to produce it in a die. And now we recollecting what does it mean to be produced in a die. At the first, we understand we need equipment, and we need something we're going to place between a RAM and a plate of equipment, table of equipment. Here it's called bolster plate. It's not bolster plate. Bolster plate, it's additional plate to place it to the table of press or whatsoever. Next, you see here is a scheme of compound die. Not even try to explain you right now how it's work. I will show you before we start explanation of task, or maybe after even. I'll show you some short videos to make your work more more understandable for you, maybe, but they are all not about what we need to do. Those things I recollect together with you right now in order you understand why we choose stamping, like for your general development of your engineering erudition, let's say. But it's not necessary for the task that we are going to do, really. So it's just to remind you what you suppose already know. Do pay attention. If we working with such stamps, typically, especially in mass production, it means that we're working with the strip. And being working with the strip, it means that we need to either to buy material in the view of strip or to make strip immediately cutting it from sheet. On the top picture, you see how it happened in a die, what we do in a die, and from two different sides. On the right, it's so-called simple die. On the left, on the left, you see simple. Yes, on the left, simple die means like little chart. I'm always mixing up where is the right, where is the left. And on the right, you see so-called combined die. It means that it may combine some different operations, like blanking and punching. They are also considered like different types of operation. It means that here you have the only punch and die block. Here you have die block and some punches. There is a difference between simple die and combined die or combined die. And the combined die in turn may be either progressive type when some working stations with different punches, and of compound type when you have the only working station which cut both outer and inner contours. Well, it's very simple, but it's not necessary for us. What the only thing that's necessary for us to understand now that results of our manufacturing, they look like this. On one hand, we have washers. On the other hand, we have scrap in the view of the strip. Do pay attention, those strips, they have distances between parts in the strip, and these distances, they are always equal if it's made by die, because die has special elements which responsible for repositioning the strip for each step, let's say. Such a step, it's called pitch. The length between steps, it's called pitch in a strip. And these devices for exact repositioning may replace the strip, or employee replace the strip manually, or some automatic device replace it. Each time to the same step, to the same pitch. And this pitch is equal, as you might see, what equal to? The pad and bridge. The pad and bridge. Each time the same bridge. Now, in this primitive scheme, there are a lot of variants of those schemes. It's very interesting, actually, but it's not the subject of our studying, neither now nor in this discipline at all. It's about elder years studying, let's say. But interesting, remind you once again. And those who studied in our university, they usually study, on one hand, the whole semester. I mean, technologies. They study this for the whole semester, all the processes of sheet stamping, including those processes. And separately, next, they do compulsory term project about tool, stamping tool designing. They do their own design of die. Well, so what is? I already said you. In mass production, they are usually working with strips. And how the strips will appear? We take piece of sheet, yeah? Aluminum sheet or steel sheet or whatsoever sheet of standard sizes. Why standard sizes? I said because usually, really, these sheets they are produced in metallurgical enterprises, as we already know, and for convenience of manufacturers who use it as semi product, these sheets they in a standard line of sizes. In our country, we have separate standards for aluminum sheets, for steel sheets, for another kinds of sheets, another kinds of metal sheets. Maybe in China it's also standardized, or at least it's possible to check the particular standard, corporate standard of some manufacturer you're going to work with. No, whatsoever. Those sheets, they are of standard sizes. You can't buy half of sheet. No, you may buy only the whole sheet for yourself. How to get strips from the ship? Well, typically, we use guillotine shear. You see, to remind you materials of one of classes before, I show you here manual guillotine for cutting of little parts. And here, better, of course, in real manufacturing, better to use something like this. Some machine with support, protected, even as you might see, it's even with special CNC stands, the special CNC device, and this device is responsible for repositioning of back gauge. It's responsible for accuracy of backward gauge for width, for accuracy of width of our strips. That is, I hope, quite understandable. It's very simple. No, in my opinion, it's simple because I get used already for 35 years for these matters. Once again, we are going to produce these washers by stamping in a die. For stamping in a die, we need strips, and inserting such strips to the die, we are obtaining ready parts. Actually, such cutting may be also where Mr. Grover, help us please, why it was opened there. Where there? Now I do not understand. Why content disappeared in this program of watching the book? I don't know. I get used, I say, to use another one. Let's forget about maybe. Until I scroll it, I will say it. The strip itself, it's not compulsory. Certainly, it's not here. I scroll to the wrong side. No, let it be here. The strip itself may be cut with those bridges. Parts may be placed in different amount and different layout. Now you see that circular parts that we no actually what is necessary for us seems like, but you see they are arranged in one strip, inside of one strip they are arranged into some lines, because if size is little, maybe more rational to use it into some lines with reducing the wastage of material. We will not try to do something so complex now. What I need you to do, we may place parts on in one line, and we may appoint bridges between them, and next we need to calculate how many parts we have in one sheet. Let's come back to slides. 8 here is and what for, which sheet to use, no, what is the size of sheet, how to select it. Usually such a sheet is selected, if you are free in your choice, it's selected in consideration, in idea that you'd like our secret point, you do remember. I hope you hear me. No, great secret, don't tell to everyone, but we'd like to save money, time, labor resources. Don't tell to anyone. Okay, and now you see material utilization ratio in our country and in our textbook. It's usually designated with Greek letter new. New, or это, whatsoever, with this letter. Uh, and this literal for each of us, it means material usage ratio. You may designate it however how you get used, maybe just by words or by abbreviation, MUR. Uh, what this material usage ratio, how to calculate it? How much of area of sheet quite clear, it's represented here with width of sheet and length of sheet. How much of this area will be used for useful purpose for the area of part. So here is area of part and amount of parts that will be produced in one sheet. No, great. How to calculate it? No, I will show the picture right now, and the same picture you see in slides. So here is the part, but we have decided, let me to show you in more scale. Part, you have decided to place it into strip, align it into one line. You have appointed what distance is between them, between these parts. And next we calculate using formula. We calculate what is the area of the part, what is material usage ratio. No problem to calculate at all. Let's imagine we know how many parts we have in one sheet already. We already know it. And after we know it, we able to calculate, as I said, you material usage ratio. What it to calculate it all if you see the same sheet? Seems like no, the same sheet, and if in one case it will be less parts, in another more parts, quite clear which one to choose. Well, yes, but what if you compare two different sheets? No, if you have choice, you may compare 2-3 variants. I should say that in your work, you're comparing 3 sheets, and what is the worst? You will do it twice. Twice because you will do it. You will see. No, I already said you 3 sheets we are going to compare, and in this case, simple amount of parts. Do forgive me, does not work because area of sheet is each time is different. It's maybe rather close, for instance, one, там, 1 meter to 2 meter and 1.2 to 1.8. It's rather close value, but it's another value anyway. So what we need to do finally for each sheet, for each variant, we need to calculate exactly this material usage ratio. Great, we've done it. No, theoretically saying it should be also checked for 2 variants of position, of strip position on the sheet, when you cut the longer side or when you cut the shorter side of the sheet and positionate the part in such a way that they are in shorter side. No, theoretically, as I said to you, and I ask you to do it twice for each sheet when you calculate it horizontally and vertically. But even for circular part, it has a point. You will see why. But theoretically, it's necessary to calculate the material usage coefficient ratio. But also, it's important that in real life, the work consists of 3 stages, let's say. First stage is to take a strip, to insert a strip into die. At this moment, employee is working. He is working, but it's so-called idle work or auxiliary work. It means that he is working, you have to pay salary for employee for this work, for this time, for his working time, but he does not produce anything at this moment. You need to understand. Parts are not appeared at this moment. Next, second stage, when strip is in a die and pull it through the die and producing the parts. In this moment, this work of employee and spends on his salary, they are useful for you either, because parts are produced during this period. And next is the third period, third stage. Third stage, when employee have finished this trip and he need to spend some seconds, no, at least half of minute, to remove the strip from the dryer, to replace it to the wastage box, and come back once again to repeat stage one, take another strip, insert it into dryer. So there are some seconds or even minutes when employee is working but do not producing anything, auxiliary time. And in your interests, to reduce this auxiliary time, it doesn't mean that you need to make your employee running between tables and press. It means to reduce it with respect to the main time. And it means if you cut the strips longer along long sheet, it will be more rational, because in this case, if let's imagine in both variants, employee able to produce 500 of parts in this cutting of strip, in this cutting of strip, 500 there, 500 here. But when strip is longer, for instance, he goes for auxiliary time 10 times, 10 strips, 500 of parts. And in this case, as strip will be twice shorter, he will go 20 times for the same 500 of parts. And in such a way, the general cost of the part will be a bit greater. Of course, it comes about, I don't know what how to express it in your money. Yeah, I know that your money are called yuans. In our country we have grivna and kopecks. In Western countries they have this dollar and cent, and the same in the euro and cents, if I'm not mistaken. It's very little portion of money, literally some kopecks in our understanding, but these some kopecks multiplied on the whole program, it will be already significant money. So better, of course, when you reduce auxiliary time, and it means that better when you cut, if possible, if no in other considerations, when you cut strip from long side of the strip, in case you have rectangular sheet, because if you have square one, no point to consider whether it's long side or short side, they are both equal. Well, people, I hope you understood. We need to calculate this material usage ratio for one strip, for two positioning of strip inside the strip, along long side, along short side. And we may calculate it. We will see how to calculate it. So let's imagine we already did it. But what? But in real life, now you see what I wrote in slide. In real life, we deal not with one sheet. We deal with, it's called volume of production. You don't need to produce 527 parts. You need to produce, in your case that I propose you, 10,000 to 20,000 and 50,000 washers. Either or. We have three variants of program. You have three different manufacturers. You are wealthy people, you see. And what is the problem may appear in this case? We will see this problem while our example of calculation right now. It may appear that after your calculation, you understand you need 5.7 sheets in one case, and maybe if you take another size of the sheet, in this case, you will need 3.5 sheets. But sheets are different in sizes, once again. And quite clear, this last piece of the last sheet, not usable, for instance. Let's imagine that it's not usable because you do not produce anything else. You pay for it, but it will be wastage in terms that it's not usable for you. And it means that in real manufacturing, it's necessary to choose not only by criteria of the only sheet wastage, but criteria of what is the volume of production and what is the more rational variant for the whole volume in terms of the whole volume of production. Now, let's try to see it an example, and after we see example, I hope it will be clear for you. Once again, I will continue in point, in this table that I have prepared to you, some explanations. And once again, show you this data, individual data for your rock. Pay attention that you have different outer diameters and inner diameters, and you have different thickness. What it affects to, you will once again explain it right now. But at this moment, at least, I ask you to pay attention that you know what is your group. No, after the list, according to the list that I place it in Mentor. So where is it? According to this yellow and green list, as I call it, you know the number of your personality according to lists of our university. Please find yourself in a list, find your variant here, not the same like it was. And in those please do find yourself in your group. If number 8, for instance, here is what number 8 in this group, it's here, thickness 2 millimeter, 2510. Here number 8 has another data, you see. And no, for reminding you, what does it mean, that to another column I left here, this color designations, thickness, outer diameter, inner diameter. I don't ask you to draw anything in scale this time, or to do complex explanations or complex drawing or something like this. It's quite enough will be elementary explanation in view of text, and couple of schemes and formula in order to understand what you refer to. Yes, and let's try to start our explanation for such a sheet, for this sheet and for some diameters. Now let me to stop on some diameter, let it be 20, for instance, really voluntary. 20, barely visible, sorry. Once again, outer diameter will be 20, inner diameter will be 10. May I already calculate the area of this circle, not circle, but ring? Yes, I may. Let's do it. What better to use? Minus divide on 4 and multiply on where to. Вот это, да? This is multiplying, and pi here exists, not exist, exist. Great. And altogether I got 2, 3, 5 and something millimeters square. Куда оно делось? And 6. 235.6 millimeters square. Next, you will see that it was not even necessary to calculate the exact area of part. It's quite enough to compare, in this particular case, quite enough to compare it by outer size, because part is very simple, and whether you're going to take into consideration this inner hole as a wastage or not, it's you might have different values of those coefficients if you take it into considerations or not, but the general tendency will be quite the same. Well, and thickness, let it be 2 millimeters. Thickness is 2 millimeters of sheet. Now, what is the question? How to appoint bridges? Bridges, good afternoon, where you disappeared, bridges. not that one. That one, да. Bridges. I show you American book right now. And in this American book, metal stamping die and their functions. No. We need chapter number 6. I even have remembered the number of page we have been. Yes. I forgot about this beautiful picture. Okay, maybe I will explain it later. For different cutting clearances in percentage of material of thickness per side. Where is it? No, it's referred. It's not. It's referred to the clearance between punch and die. Maybe it's another chapter. It's necessary to open. And no, here is shear stresses. So it's another chapter. Should be or beginning of this chapter maybe. Such data, they are usually given in the view of tables, and they are given. Wait a second. I meant to show you with proofs, but really we don't need this data. Maybe in fourth chapter they are given. These data are given for particular material, for particular thicknesses, in order, to forgive me, in order not to make engineers in the shop to think what. For soft steels, they are typically equal to, one of them between parts. It's less, the one which between edge of part and edge of strip, usually it's greater. Why it's like this? No, because strip and accuracy of strip was cut on hillet and shear, and in hillet and shear it has less accuracy of size. And what is the worst? No, maybe we will once again trying to see this picture if I find it now. Maybe I will not. Why I'm jumping? Forcing back. Stop jumping. It was necessary to take everything to slides. I thought not to overload slides for you. The shape of this place, it's not ideally cylindrical. It's not ideally straight. And while cutting in die, while cutting in hillet and shear, doesn't matter. Story is that hillet and shear even more rough than die. Die more accurate tool. And when die cutting something, this place is considered more accurate and bridges maybe a little bit less. If hillet and shear cut something, this place side considered less accurate, and that is why usually here bridges are more. For soft steels, they are approximately like this in percentage of thickness of material. When it comes about aluminum materials or, for instance, copper materials or some other materials, usually it's proposed to increase it to around 30%. When it comes about hard materials, heavy deformed metals, usually it's proposed to reduce it. Stainless steel, for instance, will be 0.9 from the bridges, from those values that obtained for soft steels. Doesn't matter. We simplify our task as only possible. We think that we're going to place parts in distance in line to the distance 1.2 thickness. Thickness each of you has different. You do remember that. Wait. That red line, it's about thicknesses. No, and blue and lilac, they are about their diameter. And side, on this side, it's a little bit greater, as I said. What does it mean? It means that we need to calculate strip pitch and strip width. I even wrote something like formula, but in this case, I hope it's completely understandable without any formulas. Well, size of part, outer size of part, we agreed it's 20. Thickness is 2 millimeter, and it means that here we have 20 plus 2.5. 2.4, sorry, 2.5. Writing one thing, pronouncing another thing. 22.4, finally. What about strip width in this case? Again, you see size of part. No, in this particular case, size of part plus couple of bridges. So we have 20 plus 4.8. 4.8. 24.8 millimeters. 24.8 millimeters. What it for? Millimeters here and respectively there. What it for? Because we are going to cut sheet and we need to understand how to how much, how many, how many parts in the only strip and how many strips in the sum sheet. Well, let's calculate. What we need to understand first. No, we have 2 meters, it means 2000 millimeters length of the strip. You see I cut it horizontally now, and I understand that pitch, the distance between parts, it's 22.4. So divided on how many parts I may do, 89. However, here it's written it's 89. So here is I have 89 parts in one sheet. And how many strips I may do? I may do 1 meter divided on 24.8. Who have not wrote 8? Me. Okay, divided onto 24.8 and 40 strips. And you see these 3 tenths and there it was some couple of tenths. It's the wastage. Так, 40 strips I may do in this case. Тут надо дописать 8 level woman attentive one. And this wastage, it's this sort of wastage from this side we have rather thin by the word. But what do we see in calculation? Like 2 tenths of pitch, 3 tenths of. But anyway, it's already wastage. No, I draw it only in order you may imagine it. Well, so how many parts altogether in this sheet? 3,560. A lot. 3, ой, sorry. Am I right at all? Maybe yes. Так, on 40. 3560. I like values. Never able to remember them. Parts. We have such amount of parts. I. And we have another variant. What is another variant? Another variant we are going to cut vertically. And in this case, we need to divide length of strip, which is equal to 1 meter, to pitch 22.4, and it will be now 44 parts in one strip, in short strip, and it will be how many strips in one sheet? 2 meter divided onto, thank you, 24.8. Thank you for myself. 24.8. How many? 80. 80. And we have wastage somewhere at the end of the sheet, from one side and from another side. And now we see we have 80 to 44. Let's calculate 80 onto 44. 3520. 3520. Oh, you see, obviously, which one is better? Obviously, this one. Yes? But now we have recollected that actually we need not 3,000 of parts, not 3.5 thousands. We need 10,000. We need 10,000 of parts. And what does it mean, my dear people? Let's ask calculator to help us again, but first it's necessary to move it a bit like this. And now we're choosing which one will be more rational in terms of all the program. Here maybe it will be no obvious decision that one. I do not understand yet. Let's see. 10,000 and these 10,000 we will divide subsequently to this amount to understand how many sheets we need and to this amount. No, let's try. I'm afraid for here and there, both here and there it will be for 10,000. 10,000 and it will be divided onto 3560. 3560. We need 3 sheets, but a little piece, no, we may use 3 sheets, we may buy 3 sheets, but a little piece, as you might see, of the sheets will be each time not necessary. 3 sheets. In this case, no, 2.8, no, really, it's for this size of the sheet. And here we have again, we have 2.8. Not possible to say which one is better. You see. In this case, in that case, obviously that one is better if we're talking about the only sheet. But as only we start consider the whole program, no difference. Okay, once again. Now let's talk about another program. I will use, for instance, another color. What, let it be now 2,000 or 20,000, to forgive me. Maybe it will give us some another effect. Maybe not. Who knows? 20,000. How many sheets we need for the left side? 3, 5, 6, 0. Замечательные цифры, нифига не запомнишь. 5.6. 5.6 of sheets. It means that altogether, how many sheets we need? 6 sheets. It's only like this. No one buy you. No one will sell you 5 sheets and 60% of another sheet. That you may understand, of course, clearly. In real life also, no one will sell you 3/4 of chicken, for instance. Так, divide on 3, 5, 20. The same problem, you see. Now it seems like it's 5.7 is used, but whatsoever, we need to buy 6 of them. 50,000. If we have manufacturing program, 50,000. Dreadful result, actually. Look, we need 14 sheets and a little piece of 15 one. 15, and it was 14, вот так, 14.04. Nightmare. And for the right side, divided onto again 15, but in this case, that 15th sheet, it's a little bit less spoiled. Да? Whatsoever. Each time seems like we have the same amount of sheets to buy. Sorry, do I have some to drink? Yes, I have sipped water. I hope it will not be repeated again. And now we may compare also, as I said, in terms of comparing with another sheets of another area. Next, we need no for choosing between these two variants. No difference practically has appeared, but no, theoretically this one we like more. But that is extremely offensive result. You see, pitiful result. And we will try to use another sizes of the sheet. Let's try to use another sizes for the same programs. I'm not yet calculated this coefficient of material usage. You've seen it. You understand it. Very well. Let's imagine that we have sheet with sizes 160 to 160 to 140, let it be 1 and 400, like this. 1 and 400. Why I then do not try to take something like 5 meter, for instance, or 3 even meter? What do you imagine yourself with a strip of length of 3 meter, twice longer than your height? And do you imagine yourself with a strip in condition of shop? No, it's not so spacey space, I would say. In order you may operate with this long strip without spoiling it, without interrupting with something, another equipment, for instance. So let's think rationally. Let's think about some conventional sizes of sheet, conventional for manufacturing, for those who operate with those such sheets. And now we need now we need to do the same. I do not understand even how it's appeared. Maybe I touched something occasionally in computer. Well, first, let's try to calculate amount of parts each time. No, each time task is the same. The only problem that I already do not remember these values. Okay, I already approximately remember these values. First, let's calculate amount of part in the one strip if we cut it horizontally, like we did it for the first time. Calculator, help us, please. And we divide it onto 22.4. 71 part. It's maybe only 71 part. Multiply it onto what? Multiply it onto, it was 24.8. Multiply it onto amount of strips. A strip width is 24.8. How many strips were you able to do? 56. 56 strips. So how many parts altogether we able to do in this variant? Oi. On 56. 3976. I hate such values. 3976 for the sheet horizontal cutting. And do repeat, but now that will be our width of strip for this side. Divided onto pitch, which equal diameter plus 2.4. 62 parts. 62 parts in one strip. How many strips? Another side, and we divide it onto width. Width equal to diameter plus 2 bridges. 24.8. 64 strips, and altogether 62, 64, 3968. 3968. Well, and now let's try to calculate it also for different programs. Obviously, once again, that this one is more rational when we're talking about the only sheet. Let's see what happened if we calculate for different programs. 9,000. Oh, 9,000. Sorry, 10,000. 10,000 onto this value. 2.5, as you might see, of sheets. No, quite clear that we have to buy 3. It was 2.51 in real calculation, but we need to buy 3 sheets, and the half of the last sheet will be spoiled. No, it's not spoiled, but it's wasted because we don't need it. You understand? Again, what dreadful results, really dreadful results. Each time is the same. It's don't help me to demonstrate something interesting. I will take the program which is not in your list, just to see, maybe we will see have some differences at all. Divided onto, on one hand, we divided onto 3976, and we need 8.8, 9 sheets we need. Yes, if I took another program, it comes about 9 sheets in one case, and it comes about, maybe it will be the same. No, so lucky I am today then. 30,000. 30,000 and divided onto, oh, I have something else. Oh, it's happened. I did some mistake. Let's repeat. Maybe I did mistake. Too much different. 30 divided onto 3976. Yes, somewhere I made mistake, people. Sorry. 7.5 and what I did? 7.5, it means that we need 7.5 and we need 8 sheets. And for another case, I spotted mistake because it was too much different result. It can't be like this. 7 and the same again. No, idiotic story, do forgive me. Meant to show you some differences. Really, differences may be depending on what sizes of sheets you take. And I took to close areas on purpose. I took to close area in this case and in that case. If we compare these areas, you will understand that it's practically the same. If you take sheets with different areas, no, for instance, here you have them 200 and 1000, and second time you take let it be 200 and 1,000 and half, something like this. No, I mean 1,500. In this case, results will be different in amount of sheets. But as I took a rather close area, of course, these results show rather close amount of sheets. But amount of sheets finally is the same, you see. Whether we use 5.6 of the sheet or 5.7, for us it will be the same because we have 6 sheets. And in this point, we may only to compare the general wastage between those two variants. As I already said, you left-right variant give you the same results, obviously. If you'd like, you may calculate the material usage area anyway for all of them all through, because it's not difficult, to be frank, yes. And actually, we see that in this case, what let it be what here, for instance, we need 3 sheets, and here we need 3 sheets. And now let's try to see what will be material usage ratio for this obviously similar amount of sheets. Let's try to see. Maybe it will be also the same. Difficult to say. I should take another values at all for sizes of sheets, as I already said you. Well, what is the formula? Remind you, it's not given here. Now, formula consider area of part multiplied on amount of parts, and where is this formula? Here is in slides. Where are the slides? Area of part on the amount of parts and divided to the area of sheet. Area of sheet is quite clear, width to the length. Don't try. No, we need this first because I do not remember any value at all. As usually. So here we have, look, no, once again, remind you, we finally will multiply it additionally to the amount of sheets. Yes, so we need to produce 10,000 of parts. Now we're talking about 10,000 of parts. We are not even interested now in this value. We need 10,000 of parts. Obviously, we need 3 sheets here and 3 sheets there, but sheets of different area. It's not quite the same formula, obviously, in use that for the only sheet. No? For the only sheet, it was formula which consider only the only part area. Amount of part multiplied onto area of the part. But now we understand that we need to produce 10,000 of part. It's our program will be area of all these 10,000 of parts. And here we have not one sheet, but 3 sheets. I hope I was clear in my explanation. Once again, people, now amount of parts, it's not one sheet, yes? It comes about the whole program. So here will be 10,000, 20,000, 50,000 in your task. No, finally, when we're talking about the material usage ratio of all the program. Here is will be the program that you need to cover with those sheets, and at the bottom, size of one sheet multiplied on the amount of necessary sheets. No, do try. Maybe we will have similar results, maybe have different results, no idea at all. 2, 3 и 5 и 6, да? 2, 3, 5, 6. Sorry, it's my way to remember the value. We need this value multiplied onto 10,000 and this 235.6 and divided onto each time it was 3 sheets, no? Divided onto 3 sheets, sheet width, sheet length. Let's try. Oh my, what happened outside? Someone stepped on the little dog, considering the sound. Then on 235.6 divided onto 3, and now first variant divided onto 2000 and divided onto 1000. 39.2 39.2 in persons. I mean, here is 39.2. Why it's so little? Because we have calculated area considering the inner hole. if we do not take into consideration this inner hole, we have another value, quite clear. Value is different, but as I already said, the tendency will be the same. Well, and now we need to calculate it for another case. Another case, we have 3 sheets. Three sheets, wait a second. We have the same program, 10,000 of parts to produce. We have the same area of part in millimeters square, which should be placed onto 3 sheets with sizes 160, no, 100, sorry, crazy woman, and 435. And what do we see? In this case, we have 35.5% this ratio. In this case, we have 39. And it means that in this case, we have less wasted material, which next cost of this wasted material is distributed to all the program. No, like it's divided between each of these 10,000 of parts. In case you have this coefficient ratio, you distribute more wastage cost between all the parts. In this case, however insufficient it looks like, no, you understand. I hope you understand the main idea that no, first criteria for us always this material usage, because it's necessary to save material, and due to this you are saving the expenses for part manufacturing. The less expenses for part manufacturing, the more you profit, my dear people. Next, when it comes about another considerations, at least you should think about how to save auxiliary time, how reduce auxiliary time. What for? In order you are paying the same salary to your employee. Employee will not suffer because of this, but moreover, I would say employee when auxiliary time, employee working more when employee working in main time, because he inserted the strip into the press. Next, he or she just sitting in front of the press and clicking the pedal, holding 2 buttons, even less work than when he's working, traveling over the shop with the strips and trying to insert it into die, remove it into die. Well, employee do not suffer. Employee don't have less salary, but you will have more parts to the same salary spent for employee. And another consideration, as I already said, you better to use longer strips in this meaning that in this case you will have more parts. No, and better to use at all those multiple positioning of parts in the same strip, in case you are working with the little parts. Those one actually they shouldn't be produced in the one line, in one row. These little creatures better to be produced like, wait a second. No, somewhere I had it. Okay, I'll repeat it. Look, what I did before, what we have seen. That parts are placed okay. Try like this. No, stop. Parts will place it like this. And due to such positioning, remind you what happened to strip. Strip was with bridges from this side, and strip was with bridges from this side. No, especially when parts are little. Look, this wastage for bridges, in case of little parts, it's practically already equal to the area of this part at all, or even greater, like we have seen in our calculations. What will be rational to do in case it's little part? Let's place parts like this. Bridges between parts in different lines will be the same. You may place it in 3 lines, in 5 lines. And what if we place them like this? Of course, there is some bridge between them, but considering that parts are of circular shape, practically if I draw some line here, look, I said if I draw a line, okay, you see, no bridge. No, I did it not in equal way, you understand. Uh, no bridge between parts already. We already saved material due to such positioning. No, in real life, in case parts are little, you may place them in 3 line, in 5 line, in 7 line, and in the so-called chess order. And at all the tendency of when we're designing the strip layout itself, before we goes into calculating of all the sheets them and so on, when we're designing the strip layout, we need to place parts in the most rational way in order amount of wastage user will be the least, the minimum. And under this consideration, next we are trying to calculate, finally, we calculate what is material usage and what is material usage for the whole program. Now, once again, all these complicated considerations, I'm not ask you to take into account at all right now. Your task is only to analyze 3 variants of programs, and 3 variants of programs you will analyze thrice with 3 variants of sheets. Let me to show once again a mentor. Oh, here is detailed instruction. I hope I was clear as never before at all. First, consider that you have 10,000 washers. Do what? Calculation for one sheet, calculation for second sheet, calculation for third sheet. After you did it, do repeat those calculations, but already for another program. No, you understand it's not necessary maybe to repeat it completely because you've seen, yes, if we have 3 variants of sheets, we understand what is the area of sheet in each time. We understand what is amount of sheet in each time of our layouts. And next, we just need to compare what amount of sheets necessary for that or another program. And finally, you may calculate the wastage. And quite clear that finally you need to see which of those sheets and for each program better to use. If you analyze 3 different sheets, you have at least 6 variants of different amounts of parts. And out of these 6 variants, the only, maybe not the only, how it's happened in our case, you may propose for to be used for that or another program. That was the whole task, actually. No, I hope it will not create you difficulties. Really, it's not complex. However much I explain it, however much I explain it and shown in those slides, where those slides are. Literally, what do you need to do? Knowing the sizes of your part to calculate the area, first. Second, take some size of sheet. What does it mean, take standard size of sheet? Now, let's imagine that these sheets, they goes either with step 100 or 200. In our country, it depends on for aluminum sheets, it's another step. For steel sheets, it's another step. Forget about. Let's think that they goes, for instance, with 100 difference or with 200 difference, and follow to this idea. Like sheets may be with sizes 1 meter, 1 meter 20, 1 meter 40, 60, 80, and 2 meters next. No, and next 2.2, 2.3, and so on. So step of sheets will be 200 millimeters, for instance. Steps of sheet sizes, I mean. And the same for the width of sheet. Either it's 1 meter or 1.2 or and so on. What size you select, for me, it's completely indifferent. I need you only to study, let's say, technique of this calculation and to try your technological calculation and to deserve some score. And after you do this, your explanatory note should not be long, people. I permit you to use any pictures from slides. Please be my guests if necessary. Just make something like print screen, If you need some piece, take it and place into your work. If you need this formula or that formula, copy and place it into your work. No problem at all. Data you may represent sequentially, may represent in tabular way, but finally, please do conclusion. Don't forget. If whole the explanation take you one sheet of A4, as for me, it will be quite normal. No, I think it's normal in this case. No, don't know what to say more for you to explain you what to do. I hope it will be not difficult. And I said that we will try to see some short videos together. Just you to remember, to recollect together with you what it looks like. Once again, I said you that sheet metal, when we're talking about sheet metal stamping, literally we're talking about sheets, profiles, and pipes. And what do you see right now? It's exactly about what do we see? No, press we don't see, but it's inside of press. And maybe it's hydraulic press, considering how slowly it's working, it's hydraulic. Let's start since beginning. Piece of pipe, place it into, there are two dies, or maybe it's one combined die. I'm not sure whether it's the same metal piece or not. Maybe there are two different dies. As for me, it's two different. One die for bending, not even for bending, it has another name of operation, plющить in our languages. No, let's call it bending because in original it was called bending. And you see what happened. On one side, they bent a piece. Beautiful, they have practically have not shown it. No, they have shown it, but it was not visible. Visible, this side is visible. And now they insert it into another die. In this another die, they have one punch for making hole, and on back side, half cylindrical punch for cutting the piece. Very simple video. Very impressive as for me. No, impressive in terms that it's simple and easy understandable. Handbook of die design. I have prepared here some pages, you see, but I didn't follow them. Those, no, they just place it in different places of books, those photos. What about considerations that I've been talking, how to place parts more rationally in case they are little, in case some, and so on. For instance, you see, example, and what parts of another shape, place it, for example, like this, just in line. Here is, they explain the difference. You may immediately cut the part of the same punch correspond to the final shape of the part. Do you see? Where it's hatchet, it's the shape of punch. And the same hole, it will be entire block. And look what these tricky people have proposed. It's not compulsory to follow to the shape of the part, making punches. Oh, sorry. Look what they propose. Punches completely different and in different places. Here is they cutting the slot. Here is they cutting this side slot and next side slot. Yes, there are three steps in this. Maybe it's everything made for one step, maybe. And I think they're replacing the. No, actually, I think it's a couple of steps here. First, it's this way, and next, it's this punch. no, considering the what is how it's drawn, I understand that it comes about 2 steps. And after no, maybe they even show it in another direction. Oh, crazy people. They show it from the left to the right, like in Arabic countries, maybe. Like they have left hand interplay. Look, that one is the first appearance, the normal appearance of the strip, and here is they use such a punch of complex shape, which is not even completely contacting with the strip. You see some piece of punches outside of strip. Cut a slot, replace part to one step, and next they cut one more slot here. And finally they once again replace it, and finally they cut it by this cutting punch in this place. What it for like this, not even ask. In this case, pointless, as for me. It's just example of what they show. But in another cases, such tricks are extremely useful. And additionally, they might help you not only uh, with the shape of the part, but also you may use some elements of preliminary cut contours for repositioning of the strip, for using it in stoppers. That one that you see here is not from the strip cut from sheet. It's so-called continuous strip or endless strip. No, it's not endless, of course, but continuous. And in this case, it's already not manual work. It's already work of automaton, which pulling the strip from another side of the die. And you see it's working automatically. Also combined die. I do not understand whether it's compound or not, but it's at least it's combined because it's cutting, punching, piercing a hole, or punching actually. Piercing it's another operation, and bending and all together. No, it's not about the sheet metal cutting, that one. I hope you already recognized the process. Process name is it's written on the bottom, of course. Thank you. Process is called bending, but what sort of the bending here is? And pay attention. It's V bending. Do pay attention to the previous step by the word. Look, punch. You see, punch move down, and part was repositioned twice in the same position. Seems like it was replaced twice. On the back side, it has these back gauges, you see, which moved automatically because this machine bending, the brake bending with CNC. And CNC in this case, mostly what it's responsible for, as I already said, for repositioning the back gauge. And employee only hold the part, like help. Here is, it's not about the metal airplane manufacturing, but it's a good video in terms that it show us how strip layout should be planned and next realize it in life. Now we see milling of light airplane made of wood, plywood, but do pay attention. Typical parts for airplane, some pieces of ribs, some maybe frames of fuselage will be. No, and what did I say? That they certainly thought about the laying out all the parts with minimum wastage, as you might see. Yes, all the empty spaces should be taken by another parts. And now we see the real speed of process. And to compare this real speed of process with this previous one, when parts appeared just in such periods of time. Now, quite clear that that one is recommended for not great sizes of parts. When you have very big amount of parts to produce, and in this case, it's necessary first to design, to manufacture, to test the die, and only then you start producing them with such a period. But when it comes about their milling from sheet, for instance, or using laser cutting from sheet, In this case, you will be able to start work maybe already tomorrow, not in some months. Of course, it's slow process. In manufacturing, it's slow, but maybe you need only one piece of each of such part. Then it's not a problem that it's slow process because you don't need thousands of parts. Laser cutting, water jet cutting. Here is what I said. Ah, I forget. I forget. Let's see what it looks like. Somewhere closer to the end of video. But here is the head of machine. It's visible. And what do we see right now? How it's moved? Thin jet of water. And this thin jet stream of water, additionally, typically now, what hop, it's already finished. Of course, it's more slow than it was in die, but again, it comes about some unique shapes of parts, and it comes about what? Time of preparation. So time of manufacturing much shorter, but time of preparation of manufacturing longer. Time of manufacturing is longer, but time of preparation equal to nothing practical. No, not quite nothing, but general idea you got, you understand. Here is discharge cutting. Remove please me text. And this discharge cutting, it's like the sort of micro explosions on the surface, and you see they show the different poles of electrical chain and directed motion of electrons inside between in the gap and the clearance between the electrode in the shape of cavity inside of part and between workpiece. Now they explaining something, but I off the sound so it's not hearable, да? But at least we might see what happened. Boom. And it's a sort of welding actually. And this that was the gas cavity which removes the particles of molten metal. Well, and finally it will be resulted in appearing of cavities inside of the part. Variants one by one. Now we see blanking dialog. It's animation, of course. Someone from project must be. Each stroke and it's cutting the piece from the strip. And oh, by the word, look, utilization of layout. Once again, I don't know, show us percent utilization of layout 62.7. No, well, because they have part practically without holes, and the only cut, this triangular cut, as you might see, what, yeah? A big cut, no, it's around 30% of area of the part itself, and part is big enough. And in this case, the percentage of those bridges, which depends above the all, they depends on the thickness of material and the property of material. And on second point, they depends also what contour we have, whether this contour is straight or circular. No, some more videos literally what to entertain you. It's again the bending machine. You already understood. Look, the whole stack of parts in front of employee, and employee just need to remember what side to insert next of the part, what edge to insert, and machine will employee do not even think or try to measure something. Pay attention. Whether it's he or she, this person just attach. By the word, very interesting moment. Attach the part to the back gauge, and we have seen moment of inspection and pay attention. What he use? He use that is measuring tool. It's tool for with units, let's say. And in some videos, we might see how they attach not tool with units like no, second was vernier caliper, and first of all was angle measurer. It's possible to attach to part some no, something like standard of this part or of elements of this part. So call it template. Template which repeating either contours of part or holes in the part, and you attach example, let's say, of part or some feature of this part, attach it to the part, watch coincidence, and make sure that it's inside of some limit of sizes. That is somehow similar to using of gauges in the method of interchangeability providing that maybe you have already studied. What and that one, despite its I wrote sharing 2 years ago when I downloaded it to my soft library, let's call it like this. No sharing here. I check it sometimes. It's only about bending, especially it's about V bending. And thanks to SME, as usual, Singapore mechanical engineering company or metal engineering company, something like this. They produce time to time very interesting short video with explanations, like directed to students. Of course, they produce it as the sort of advertising of them, but thanks to them, we may demonstrate next such short, understandable, and simple video with good English. If you not mind, I'll send you these little videos separately, and then you may listen it with the sound. Above all, I'm talking about the video where at least any explanation provided. And here is one more interesting moment, but maybe this will be too complicated for us yet. Look, there are punches visible and holes in a die, you see. Yes? We have not maybe spotted all the holes and all the punches. What you see, little one, cylindrical one on this side, inside, what they made holes. And additionally, they made cut on the side. Next step, and it's appeared apart, but it's already under the die. It's already fallen down under the die. And they made couple of holes for the next parts. It's so-called progressive die work. You see, it's already another part has appeared and another couples of holes has appeared for the next part. And finally, they will continue, and continue. Well, there are parts you might see. And moreover, what these tricky people do, look, once again, we have witnessed that when they do something, it's only with big clearances between parts. Yes, like this. But why? Here we see the strip without any clearances. It's so-called stamping with rotation of the strip to save material. First, we're passing the only line with clearances for another part. And next we rotate it 190 degree. Let's take like this in order to, it's not maybe rotated later. They have another punch immediately in the die. Oh, I forgot. But it's maybe done like I said. You use couple of punches only for blanking, one punch, and for punch for holes. And next you just rotate these parts, not parts, but the strip. After you remove it from die, you rotate it to another side and start it again since beginning. No, in their case, they did more complicated die, but thanks to them, we may see what does it mean efficient usage of material while stamping. Next, it comes about dies themselves, the short videos. So maybe it's too much for you. It's already, I'm afraid you already overloaded with this, and maybe you already hurry to go to start your task. Good luck. Do start your task. If any problem, don't be afraid to say. Don't be afraid to ask, and maybe we will repeat it something again.